All right, I think we are getting ready to start. So Sue, you can go ahead and get us started.
Sorry, I was muted. So do you see my full screen or what do you see?
We see you.
Oh, really? Oh, okay. Okay. What do you see now? Good.
We're good to go.
Good. Hi, everyone. I see 16 people joining today with us, and welcome to the symposium, and thank you for joining us on Friday afternoon. I don't think we need to wait for people, so our symposium title is Insights on Text-to-Speech as a Universal Design Feature, NAEP Mathematics Process Data. I'd like to introduce today's presenters from AIR, American Institute for Research, Sue Lee, me, Juanita Hicks, and Ruhan Sersi. So we've broken down the symposium into 5 sections. So 1, introduction, 2, evaluation of the text-to-speech tool using NAEP process data, and 3, exploration of TTS using the differential boost framework, and 4, exploring read aloud sentences to understand learners' TTS use tendency, and 5, implications and recommendations for the future study. Just to mention that we're only going to take 1 or 2 questions after each presentation, but we will have more time for questions at the end of the symposium during the Q&A. So I'd like to introduce Juanita, who will provide a general background for this symposium. Juanita?
Sure, go to the next slide, please.
Sure.
Great. So the text-to-speech technology really started in the late 80s, and because of the growth of computer and digitally based assessments, the text-to-speech feature, first as an accommodation, but now as a UD feature, has been gaining some traction and has gotten a lot of attention from researchers in a bunch of different fields, but mostly the special education field and the accessibility field. So NAEP, which is the National Assessment of Educational Progress, once was a paper-based assessment, but it transitioned to the digitally based assessment in 2017 for math and reading for those 2 subjects. One of the reasons is NAEP wanted to improve the accessibility for all students that are taking the assessment, since it's a national assessment. And so in that, it uses some elements from the universal design. And because of that, NAEP has a host of universal design features which are available for all students to use. And so one of those features is the text-to-speech tool that which will be the focus of today's symposium presentation. Next, please. So I'll talk a little bit about some of the previous work and literature in the field around text-to-speech, which is also known as read aloud. So I'll try to make it very clear when I'm talking about the actual accommodation versus the actual UD feature, the universal design feature. So the read aloud accommodation is actually was first. And this accommodation involved live reading by a teacher or an aide, but mostly just a human reader. And so you can imagine that there are certain problems which might happen when you have a human reader reading things to a student during a test. And so one of those is a human reader there can be some variation in what the reader is reading. So you can mispronounce a word like I just did right now, or you can misread something which may affect the student who is listening to you for this accommodation. Another issue is that for a human reader, we are not always aware of how things are coming out. We just know what we're reading. So you may inadvertently affect a student and like give them a hint or a non-hint about what you're reading. So you may have a long pause at a word, or you may intonate on a certain word and the student will pick up on that and they're thinking, well, maybe this is important for what I'm about to do. So there are a bunch of different types of issues that can happen with a human reader, with a live reader. And so some of these unintended effects of that particular accommodation really led to the consideration for different approaches. And you're thinking, well, if I want to create an assessment that is equitable and fair for all of the students that are involved, but especially for the students who actually need this accommodation, we may need to rethink how we can better provide the accommodation. And so the read aloud accommodation was transitioned to the text-to-speech universal design feature. And so if you're familiar with text-to-speech, then it is exactly as it sounds. Text on a screen is now spoken to you through like an audible voice on your computer or laptop or desktop or tablet, whatever the student or whomever is using it. And the reason why you want to have something like that is because now it cuts down on some of the unintended effects and the inappropriate use that I mentioned as a live reader. So a text-to-speech audible reader, assuming that there are no glitches in the system, will give you a consistent reading of whatever the text is, almost always. There is just one voice, which is the computer voice or whoever's voice it is. And it's also individualized and it's independent. So a student who is using the text-to-speech feature, and if they have earphones like I'm wearing now, then they hear the text in their own ear and no one else knows that they are using it, which is actually great because there's been a lot of research which suggested that students may have been reluctant to use the read aloud accommodation when it was given by a live reader, because they may feel like they don't want to ask their human reader to reread something, because let's assume that that student is not in a room by themselves, then other students around can hear student X asked to have the teacher read paragraph Y twice. So you cut down on things like that when you give the student an individualized, independent UD feature like the text-to-speech. And also it's self-paced, so the student can choose when they would like to use the text-to-speech tool. They can choose how many times they like to use the text-to-speech tool, and depending on the system that the text-to-speech is provided on, students can either slow down or speed up the reader's voice, so they could basically make it their own and help them as much as possible as they're using it. Next slide, please. So what we really wanted to explore was how text-to-speech technology affects users' experience in the NAEP assessment since it's provided. And we know based on literature that text-to-speech is one of the most commonly used and studied accommodations for students. But there actually isn't a lot of research on text-to-speech as its own UD feature, especially in a digital context. And so we wanted to contrast the literature on text-to-speech or read aloud as an accommodation with what we are seeing and investigating in a digital context and how students use the tool there. So now I'm going to turn it over to Ruhan, and she was going to give you guys an example, or she's going to show you an example of how the text-to-speech tool is used in the NAEP digital context.
Hi, everybody. So as Vanita mentioned, we would love to show you an example that what actually text-to-speech feature and how it works in NAEP digital system. So this is a screenshot taken from the NAEP questions tool, which is available online, and you will find the website address on the next slide. And this is a screenshot of a grade 4 mathematics item. So you will see that this represents the actual digital platform and the features that has been embedded in this digital platform. So there's some content about the item, and there's an item stamp, and there are some options that students will be drag and drop to the boxes at the bottom of this item, and they may use some features on their on tablet, and the feature text to speech feature has to be activated to be able to use. So what student does that they click on this capital letter T with some thinking bubble just above it. This represents the text to speech. Yes. Next slide, please. So when they click on that button, actually, some stuff happens in terms of the data collection. So it is recorded that text-to-speech feature is on now because students click on this button. Then, as you realize, there are some blue boxes around each part of this item, including the content of the item, for example, in sentence, item stem, and around the figure that we see as grids at the bottom. So what happens, students click on each of these boxes if they want to listen to any of that features online. So this is how the text-to-speech feature works on the NAEP items. But it is possible that students will not click on any of these blue boxes, so and maybe move to the next item, or just we click on this text to speech button at the top of the page, then it will turn off again. Next slide, please. So based on this feature and collected data related to this feature, this symposium actually used data from the 2017 National Assessment of Educational Progress digitally based grade for mathematics data. And we use, just as an example, one of the blocks available for the NAEP assessment, which has a 30-minute time limit. And this block includes 14 items in it. When we look for our samples across these studies that has been included in this symposium, you will hear that we make some analysis with the sample data that includes students who had no accommodation, almost 26,000 students who had any type of the accommodations, because NAEP actually provides multiple number of the accommodations for students, and it's almost 3,000 students, and data for students who received the extended time accommodation, which is included also in any type of accommodations for the analysis. Next slide, please. So again, across the studies included in this symposium, you will hear about some variables, and we categorize these variables into two. One of them are we call the derived variables, and we derive these new variables from the process data. One of them is text-to-speech on and off mode, which is a binary variable. And as we just mentioned, students may click on the text-to-speech button to activate this function. They may not click on any of the blue boxes with any content to listen to. So there is, and this creates one binary variable. But to be able to listen any of the any part of the items, also they have to turn text-to-speech button on first. Then the second variable is text-to-speech sentence. So as we just see in our example, if students click to listen to any of the elements belong to an item, this will be also logged in the data, inside the process data. So we know actually which part of the items they are listening to. The next derived variable is text-to-speech item location. And again, it can be the item's theme, it can be the item content, response options, or any of the figures or the tables that there is some read a lot text available under the table or the graphic. And text-to-speech sentence length is another variable that we extracted for the final study, and we calculate the length of a sentence in terms of how many words it includes or how many characters are included in the sentence. We also have some standard variables like the demographics, like gender and ethnicity. We also use some of the item characteristics. For example, the item sequence number, if item is presented on the first order or the second or is the last, that in this data set we have 14 items. And we include some analysis with the plausible values in the second study. So these are all general information about the data and the other stuff that we will be presenting as in separate 3 studies for the symposium. So I will turn over to Sue, who will present the first study, which explore text-to-speech use with the process data.
Thank you, Ruhan. Okay, so I will explain the study 1, evaluation of the text-to-speech TTS tool using NAEP process data. The main goal of this study 1 is to provide a better understanding of the differences in examinees' use of the TTS tool using process data. Specifically, our focus is on number 1, examining the association between TTS use and students with and without receiving accommodation, that is accommodated group versus non-accommodated group. 2, evaluating result to examining differences in the accommodated group, or we call the general accommodation group later, versus extended time accommodation group. So I want to mention that study 1 is basically all descriptive and exploratory analysis to set a foundation for the other studies. 2 situations were considered for these studies were, first, this situation is student who turned TTS on and selected at least one read aloud sentence before turning TTS off. We consider this group as TTS use or true TTS use group. Second situation is students who turned TTS on and off, but failed to select any read aloud sentences. Therefore, research questions for study 1 are, number 1, do students who truly use TTS, that is, selected an item part to be read aloud, differ across accommodation condition? 2, how does TTS use differ across major reporting student group under accommodation conditions? And 3, does TTS use differ across items? This figure shows the result of the percentage of students use, percentage of accommodated students on and off, and true TTS use. Again, true use group defines the student who turned the TTS on and selected at least one read aloud sentence before turning it off. As you can see, the figure shows the regardless of the item sequence here. And the percentage of students on and off are much lower than the students TTS true use group. However, item 4 in here, the red circles, is the exception, which showed a much lower percentage of true TTS use compared to the other. So the next slide, I want to show you why what kind of item is item number 4 and why true TTS is lower than other items. So these are MA blocks we use for this symposium. And number 4 item I'd like to show, and this is a fill in the blank and relatively easy difficulty or moderately difficult 0.298. And this, the item is divide 3-digit the whole number by 1-digit whole number. So this is number 4 item, but this is the student used TTS quite low. This figure addresses research question 1, the percentage of true TTSU's student between the 3 accommodation conditions. 3 accommodation conditions are extended time accommodation, general accommodation, and no accommodation. There was a similar pattern for extended time accommodation group and general accommodation group across the item sequence of true TTSUs. Whereas the percentage of true TTSUs for non-accommodated group was much lower as expected. But again, item number 4 shows very similar pattern as before. To answer research question 2, we explore true TTSUs within accommodation group by major reporting student groups. For example, variables sex, race, ethnicity, student disability, and English language learner. A similar pattern of true TTSUs was found between accommodated and extended time accommodated student group in all major reporting student group, whereas non-accommodated student group shows distinct pattern. For example, male students 64% and 62% use TTS more compared to female student in the accommodated and extended time accommodated student group. But female and male student almost equally used TTS tool in the non-accommodated group. It is also very interesting to note that about 95% of students who do not have IEP, that is individualized educational plan, they use the TTS tool under non-accommodated group, and 92% of students who are not in English language learner group, they use 92% TTS tool in non-accommodated student group. Whereas only 37, when you compare to the English language learner group, only 37% of accommodated students group and 40% of extended time accommodated student group, they used the TTS. To answer the research question 3, we explore the percentage of students using TTS for each item for each accommodation group. The percentage of true TTS use for non-accommodated group ranged from 3 to 18%, and extended time accommodation and also accommodated group ranged from 6 to 23%. Due to the space limit, this table only shows the items with highest TTS used for both non-accommodated and extended time accommodation group. So as you can see, the yellow highlight and the green highlight, across all accommodation group, composite CR item 12 is the highest use among the non-accommodated and extended time accommodation group. So 18% and 23%. And also you can see the item has very difficult item. And composite CR means composite constructed response item. And as you can see, the yellow highlights, the MCSS item, which means the multiple choice single select item, item number 5, has a moderate difficulty, 0.35. It's been used 22% of the extended time accommodation group students and 15% of the non-accommodated group. Surprisingly, a moderate difficulty, 0.35, but straightforward MCSS item 5 had among the highest percentage of students using TTS. In a summary, first, a high percentage of students across all accommodation groups use TTS on a moderately difficult MCSS item 5 you just see. And the item is not very text heavy, but to the grade 4 students, it could be contextually very complex. And 3, and also it is very interesting result because the item was not a traditionally difficult item like composite CR item. Composite CR item has very difficulty parameters 3.25, but relatively item number 5 shows 0.35. So it was very interesting found. And second, in general, similar pattern of TTS use between accommodated and extended time accommodated group in all major reporting student groups was found. And 3, this study can contribute to research on use of TTS feature as a universal design element in large-scale assessment like NAEP. Although these results are very informative, there are some always limitations should be addressed. First, this study focused on relatively very small number of items, only 14 items from one released block. And second, this study focused only on grade 4. So future study would benefit from including other grades, grade 8 and grade 12, possibly to explore the generalized effects of the TTS use. So Ruhan, is there any question to study 1? Then I can answer 1 or 2.
Yeah, so I just see one question in the chat box, and because we have, we are just 16 people in that symposium. If anybody has questions, please feel free to unmute yourself and ask questions about this study 1. So the question that we have from Jihang, I hope that I am pronouncing your name correct. I'm sorry if I am not. So how can we have access to the NAEP process data? And I think I can answer that.
Yeah. Please.
Okay. So NCS currently has the NAEP process data, and NCS has in the middle of a process. If you Google it, NAEP process data, you will be able to find the first look report on the web. Then you can find the details about, the NAEP process data and what are the plans to release it. So there's not an exact date that this data will be available as a restricted use data. This is very important to keep in mind. So it will come as a restricted use data set, and probably, so not, again, not clear, but probably you need to follow the same procedures that has been applied to the NAEP data sets, how to get access to NAEP student response data sets, the same procedures to apply for a restricted use data access, and you will be able to get it. But you need to follow NCS website, and specifically the information or the announcements about the NAEP process data to learn how you can have or when you can have access to NAEP process data. I hope that it's a clear answer. Okay.
Thank
Great.
you, Rupan.
Yeah, thank you. So is there anybody else with any other questions? Okay,
You can always ask at the end of the symposium.
Absolutely. We will have time, as Sue mentioned, more time for the questions about any of the studies at the end of the symposium. Okay.
As a wrap up, my study defines the TTS use and explored how students use TTS feature, but the second presentation from Juanita will focus on exploring the relationship between TTS use and student performance. So now Juanita will share her screen. Hi, Juanita.
All right, thank you, Sue. So yes, so basically Sue gave us like an introduction into the text-to-speech use for the different students in the different accommodation groups, so non-accommodated versus accommodated. So naturally our next step was to figure out if that text-to-speech use or not use affected student performance or their NAEP student performance. So if you're unfamiliar with NAEP, there's a very, it's not complicated, but there's a very strategic way in which students are given the NAEP assessment. And so students are randomly selected, and there's a different stratified approach. So students from schools are randomly selected, but they are not randomly assigned. So in order for us to do our comparison, we knew we couldn't take that true traditional experimental approach. So instead what we did is we just created a match sample of students within each accommodation status group. So for all non-accommodated students, we split them up for non-accommodated students who did not use text-to-speech and who did use text-to-speech. And then we matched students in each group so that we can have some comparison samples. And then we repeated that again for students in the accommodation group. So these are students who have accommodations, who did use text-to-speech and who did not use text-to-speech. And then we also matched them using propensity score analyses for different covariates. And so some of those covariates were gender, race, ethnicity, students' SD status, ELL status, and National School Lunch Program eligibility. And then what we did is, given that we had two separate groups, we knew we couldn't do a direct comparison between them because they are obviously different, non-accommodated versus accommodated. So we just took a different approach, which is a difference in differences. And so basically what that means is that we looked at the difference in performance for the non-accommodated students and the difference in performance for the accommodated students. And we just do like an observational comparison between those two samples. Okay, so that research setup led to our research questions. So the first research question is, we wanted to know is if there was a difference in performance between non-accommodated students who do not use TTS and non-accommodated students who do use TTS. Repeat that question for the accommodated students for research question 2. And for research question 3, like I said, not the direct comparison, but an observational comparison between the performance for non-accommodated students who use text-to-speech and accommodated students who use text-to-speech. And once we look at that performance difference, we wanted to know if it satisfies the differential boost hypothesis. And so let me, before we go on, let me just give you a quick introduction into that. So when you are examining the effect of an accommodation in the traditional literature, there are two widely accepted hypotheses. One is the differential boost, and one is the interaction hypothesis. So the differential boost hypothesis says that the effect of an accommodation, any accommodation that it is, will positively impact the target group, which is mostly accommodated students. And it will also positively affect the control group, which are the non-accommodated students. However, the effect, the positive effect, will be larger for the accommodated students. And the interaction hypothesis is a little bit more strict, and that hypothesis says that actually the accommodation will only positively impact the target group, which is the accommodated group, but it will not have a positive impact for the control group, which are the non-accommodated students. So we wanted to, based on the performance of the two groups and the text-to-speech use, we wanted to know which of those hypotheses our results would fall in. And the reason we didn't really take a directional approach because in the literature, actually, I think there are about 25 studies we reviewed, and each of them in their results indicated either an interaction hypothesis or a differential boost hypothesis. So there was no strong suggestion for either one, but both have been found. And I guess it just depends on the study or the sample. So we wanted to know where we fall and maybe some of the reasons why. So for some of the results of our sample, I just talked about the match sample. If you're not familiar with the propensity score matching approach. So basically when you're trying to match your students, you have an initial imbalance on your selected covariates, and in this first graph on the left, you see that it says S-Lunch1, which is our national school lunch eligibility covariate, that is slightly imbalanced. Excuse me, there we go. It's slightly imbalanced before propensity score matching. And then after we use the propensity score matching and we use the optimal matching option or approach, then you can see that actually all of our covariates are in line. So this is what we use to make sure we have as close as possible, really good matches for all of our students in each of the groups. So we did this for the non-accommodated students and for the accommodated students to get our samples. Then once we did that, we compared their performance differences using the plausible values that are provided in NAEP. So to answer research question 1, which was for the non-accommodated students, we're looking at this table here. So the unadjusted mean difference is just exactly what it is. It's the mean difference between the performance for students who did not use TTS and students who did use TTS. The PS adjustment, which is the propensity score adjustment, is after we adjust on the propensity score matching method, and the doubly robust is after we adjust based on the propensity score and the covariate selection. So it's just a little bit better. So for the non-accommodated estimates, you can see that they're all negative. In this case, in actually both cases, the estimate is text-to-speech use minus non-text-to-speech use. So basically what that suggests is for the non-accommodated students who use text-to-speech, their performance is actually slightly lower than non-accommodated students who do not use text-to-speech. And on the flip side, on the reverse, we see that it's different for accommodated students. For accommodated students who do use text-to-speech, their performance is slightly better than the accommodated students who do not use text-to-speech. And then when we compare the performance between the accommodation groups, which is again observational because we cannot do a direct comparison because they are different. One group has accommodations, one group does not. We see that the result is the use of text-to-speech differentially affects the non-accommodated students and the accommodated students. So in the literature, like I mentioned before, this is actually, it's not a conclusion for the interaction hypothesis, but it does suggest it, which is that there is a significant positive impact on students in the target group, which is the accommodated group, but we do not see this for the control group, which is the non-accommodated group. So that leads us to a few different questions that we have. And again, this is an exploratory study, so we don't have definite conclusions, and this is not extremely generalizable, but we do have some ideas about future research to tap into this a little bit more. And one of them is to explore the text-to-speech feature, or at least the use of it, to see how it functions. And by that we mean, is it functioning as intended, or is it functioning as a distraction? And so the reason we think that is because, as we've just seen, for text-to-speech, for non-accommodated students who use text-to-speech, we see that their performance is slightly lower than the same group of students who do not use text-to-speech. So you would start to think, okay, if this universal design feature is available for all students, and I should also note, the reason why this is so important is because the text-to-speech feature or the read aloud accommodation was only available for students who had accommodations. But making it a universal design feature means it's available to everyone. So that means students who historically would not have had access to it because they did not have an accommodation now do have access to it. And we see that they are using it because in Sue's study, we saw that 92% or 95% of non-IEP, non-accommodated students use this tool, which is a lot. But we also see that the use of this tool for those same group of students is negatively impacting their scores. So maybe there is something going on where the consistent and high use of this tool for students who may not need it is a distraction. Whereas the same use of the tool for the students who would have had access to it traditionally, which are the accommodated students, is actually functioning as intended for them, which is provided to help them. So we cannot tease that apart yet because we don't have enough information, but based on our results, we know that this is a direction we'd like to go in to look a little deeper. And we're also thinking, well, if this differentially affects non-accommodated and accommodated students, then we might want to look at preparedness for these diverse learners. And by that we mean, we know in actual instruction, there's different instruction practices for students who are accommodated and students who are not accommodated. And so you might also want to think about that when teaching students how to use these UD features. So yeah, I think that is all for my section. And if there are any questions about paper 2, I'm happy to answer them. Okay, maybe not. So if not, I guess we will move on to paper 3. And of course, if you just need some time there, we have plenty of time at the end to answer questions. So now I'm going to turn it over to Ruhan, and she will look at the effect of text-to-speech use and how that relates to item and item characteristics.
Thank you, Anita. So I will be just sharing my screen. So far what we did, we look for who is using this text-to-speech feature actively, as in the way that we are defining as a true text-to-speech feature use. And then we look for how it relates to the student performance. So in this third study, actually, we take our focus from the students to the items, because actual sentences that students are listening to actually provide a rich source for us to explore, and it kind of created some questions in our minds that, okay, why they are selecting these sentences, and if there's any driving force for that tendency to use the text-to-speech tool on that. I'm sorry, I will go to the study 3 now. So for that study, we extract the sentences that students actually use text-to-speech feature in the digital system. Then we identify and explore some of the sentence features using the natural language processing. So natural language processing is a very, very big field. So what we will be presenting today is just the initial results and just some explorations of these sentences. Related research questions for the study is that what are the most common sentences listened to by students? And second, okay, if we can extract the sentences from the process data, what are some characteristics of these sentences, such as length and the place? And if there are, if we can identify where these sentences are embedded, if it is either the stem or the response option, in which of the items among this 14 that we are exploring in that study, if they are attached to just one item or all of the items, how it differ. And the last question that we have, if we can identify complex sentences, or if we can look for the some characteristics of these sentences, if there's a very complex sentence, if we can simplify them. For the last part, if we can simplify these complex sentences, this is an ongoing study, so we will not be sharing the results for that part. So to address our first research question, which is what are the most common sentences listened to by students? So when we look at the numbers, we just count the number of the unique students, because remember that students actually may re-listen to the same sentence, same sentence, and it can be in their first visit of this item or across different visits. So when we look for the unique number of students, we see that there's not extremely large among the whole sample that we are using in this study, but still there are some students that they listen to these sentences. And when we explore that, for example, the first one, the sentence that they listen to is, after the first number, each number in the pattern is 7 more than the previous number. So a lot of students just listen to that sentence, and this sentence belongs to item 5. And we already highlighted item 5 and 12, as you will remember from study 1, that students really use text-to-speech tool extensively on these 2 items. So this item is a moderately difficult multiple choice single select item, and its order is 5. And if you look at the other 4 sentences on this table, you will see that the 4 sentences belong to item 12, and item 12 was one of the hardest items in that block that students take. Then to address the second research questions, okay, if these are the sentences that we extracted to explore across all the items, what are the number of the students and how it relates to the length of the sentence that they are listening to? For that purpose, actually, what we did, we classified the sentences into short sentence, medium sentence, and long sentence length. Then we look for the relationship. You can see from this graph that there's not a clear pattern actually how if there's a, the expectation or hypothesis may be that if the length of the sentence is too long, students may tend to use the text-to-speech feature. But what we find actually, more students more tend to use the text-to-speech feature on the medium length sentences, which means that the sentences have words between 9 and 16. And when we look for the sentences, again, across all the items included in this study, for 14 items specifically, we look for, okay, where this text-to-speech listen to sentences or the parts come from. What we find is actually half of these sentences belong to the item stems. In this study, we didn't differentiate between the item stem in the item content. So it includes both. And 41% of this sentences comes from the answer options or question prompts themselves. And only 9% comes from the diagram contents, including the tables or the figures. But still, this information provides us with some additional idea that how students are using text-to-speech tool across all items. Then to actually explore our third research question, okay, if we just focus on the words within the sentences, can we learn a little bit more about how these words are contributing to this text-to-speech use? So for that purpose, what we did, we pre-processed the sentences that we extracted from the data, and we conduct some tokenization, which means that we chopped up the words from the given sentence into a sequence of words and phrases And we also remove the punctuation, we split the text into the individual words, and we excluded the common words from the sentences. For example, like a, and, the, or we, you. So after excluding that, we have a corpus of the words, and we would love to explore if this word corpus of the words create some clusters that we can extract some more meaning from them. So, but just inspecting this diagram on this slide, actually, we identify 5 different clusters. And it is hard for us without the content experts to actually make sense of it. But what we observed from just these clusters, that still the words, for example, the numbers like 1, 2, 3 that you can see on the fourth cluster here, like 801, 3, these are just used as the numbers inside the sentences. But when they are used associated with the other words, for example, 5 grade or 5 grids or 3 2 shapes, then they are clustered as a different group. So it means that, you know, the words complexity or the difficulty may create some clusters, but we are looking for some collaboration with our content experts to make sense of what we are observing here exactly. Further than clustering, what we did, we also explored the sentences for the easiness of reading and the complexity. For that purpose, we go back to the linguistics, and linguistics provides some simple but simple tools how you can rank or how you can measure the read easiness and the complexity of each text that you are providing. In our case, what we did, we combined the sentences that the text-to-speech tool has been used for each item. So we can think that we created 14 different sentence corpuses here for 14 items. Then for the sentences that didn't use text-to-speech tool, we extracted flash and the type token ratio measures, which has been used in the field of linguistics, but there are a bunch of discussions about them, how they are useful, or if they are affected highly by the length of the text. And there are other measures that we can use for that purpose. But for the this presentation purposes, we are just providing these 2 measures. And here what we are seeing on the table, actually, item sequence, because we have 14 items, then item difficulty for each item, and these 2 measures. From the practical side, the higher the flash score, it is easier to read. So we again know that students highly use the text-to-speech tool for item 5, moderate difficulty, and for item 12. Then we'll look for, okay, how easy these items, the sentences in these items that students use the text-to-speech tool actually easy or difficult. The higher the score, it is easier to read. So you can, and this is a comparative measure. So we can see, for example, these are not extremely hard to read items among the others. We have item 4, which has the one of the lowest scores, which means that it's hard to read this item. What we know from the first study that actually a very small number of students use the text-to-speech tool on that item. And when we look to the other measure that we are using, type token ratio, we are again seeing that higher this measure, the higher lexical complexity. So we are seeing that the item 4 is very high, and also item 7, which has been that accommodated students actually use the text-to-speech feature in a high percentages for that item, and this is a high item with high lexical complexity in terms of the sentences that students use, students read a lot or listen to. So just to provide a quick summary on that study, again, this is another exploratory study, and this is a new way of looking at the data that we have using a different methodology. So the most common text-to-speech selected sentences we see that belong to these two different items with very different item characteristics, but we didn't have a chance to differentiate this for different student groups yet. And we have a sense that students may use the text-to-speech feature on a text-heavy item because they don't want to read all of it, or they want it can be easier to listen to, like item 12. However, we are kind of not, we don't have a hypothesis why they are using the text-to-speech tool on a low text item like the item 5 that we already see. And again, this is why we need some linguistic contribution rather than the text heaviness if this is a complex text that has been provided in this item. And we believe that our study will be helpful, and definitely there will be need more exploration of to identify or to explore the optimum sentence and the word characteristics using the data coming from the process data. And this is end of my presentation. So if anybody have any questions, I'm happy to answer.
So we don't have any questions yet for the study 3, but if you would allow me, I'd like to share my screen so that we can show the participants item 5 and item 12 so that they can really see the differences between them, and they can start to think of maybe their own conclusion about why text-to-speech is used so differently on those two items.
Yeah, I think that's a very good idea actually to look at these items indeed.
Great. So, like I said, we mentioned before in study 1 and study 3 that item 5 and item 12 came up multiple times, but for different reasons. So the item on the left is item 5, and what we describe this as is it's a not text-heavy item because there's only a few things you actually need to read. The item stem, the prompt, what it's asking you to do, and then choosing your answer. And then you can see for item 12, there is actually a lot of text on this item, and then you actually have to only answer 4 things here, 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 and here, but you do have to read a lot to be able to do that. So I think maybe for us coming in, or maybe for others, is that we would probably assume, our natural assumption would be that text-to-speech would be used on text-heavy items, like item 12. That makes sense. But if we're just going on text heaviness, then that does not explain why item 5 also has a lot of text-to-speech. So our text heaviness approach maybe is not, it's not a full answer. It's maybe half of the answer. But then if we look at results from Ruhan's study in study 3, and we look at the FLESH scores and the TTR scores, the FLESH scores for item 5 and item 12 suggest that they are somewhat easy to read. And that's just by typical word complexity. The words in item 12 are not very, they're not very hard. They're not maybe very difficult for 4th grade students. But maybe in item 5, this sentence after the first number, each number in the pattern is 7 more than the previous number. Maybe that is a little confusing for 4th grade students, even though technically it is a sentence that is easy to read. So maybe text or read easiness is also not a sufficient answer. It explains half of it, but not all of it. And then we look at the TTR ratio that Ruhan provided, which is lexical complexity. And we also see that item 5 and item 12 were not very, they did not have very high values. on the TTR. But again, we know that students are using text-to-speech a lot on these two items. So again, none of those individual answers or none of those individual approaches is an answer to why text-to-speech is used so heavily. And I think individually, each of us may think that that is an appropriate reason. And so we are tending to think more about an integration, right, of all of these things: text heaviness, ease of reading, and lexical complexity, in addition to item difficulty, of course, to maybe sort of triangulate those three things to figure out why text-to-speech would be used so much for completely different items such as these. So again, that's part of our work for this exploratory study. We like to, to really hone in on why that is the case, because then we'd be better to understand when text-to-speech would be used. Because I think our natural assumption for the three of us is we understand why text-to-speech is used on item 12, but maybe not item 5. And so the more we learn about the difference in the items and the way text-to-speech is used, the better we can, like I said, triangulate all of the approaches that we have to sort of figure out what's really going on and what might lead students to use text-to-speech, especially between the two different accommodation groups.
Thank you for sharing the screen, Juanita. And I think I just see the Marian's comments on it. And Marian, we totally agree, actually. She's saying that, item 5 wasn't natural in terms of how we talk and was critical to getting the item right. So she says that I have no idea how to quantify that, though. And this is, I think, why it makes it as an interesting work that we are, putting some effort into that. And we agree when we look for the sentences. I was like, oh, it's a little bit hard to make sense of it. And if as a fourth grader, it can be even more difficult. This is why we would love to collaborate with our content experts, definitely. There's a question from Sat. I hope that I'm again saying the name correct. For study 3, what ideas do you plan to explore getting optimal characteristics? This study actually has a lot of angles coming with it. For example, we would love to make some analysis using all of the item contents. Then we would love to compare it compare these characteristics with the sentences that students using with the text-to-speech tool as well. But also, this data provides some other information. The process data may provide some other information, not for NAEP, but in similar data sets, you can see that where students are highlighting. So which sentences have been highlighted already in some other characteristics as well. So we are hoping that, we can get some other information from the data to look more in depth to explore the sentences. And again, this is only 14 items, and NAEP has 10 different blocks, at least for grade 4, and the item pool is quite large. Actually, when we move to exploring more items, we hope that we will be able to make a better sense of the trends that are coming from the data. But currently, we are using some natural language processing approaches, including the text mining, exploring the text complexity, or if we think that there's a very complex sentence, how we can simplify it. I hope that this answered the question. Okay, that's great. So this is the end of our 3 presentations, but for the symposium, we have a discussion. So I would love to give it to Heather to share her reflections on about these 3 studies. Heather, it is on to you.
Oh, Heather, you're muted.
There we go. Thank you. Thank you, Juanita, Rohan, and Sue. I appreciate you inviting me to be a discussant. I just have a few slides and a few reactions to this line of work and just a few comments specific to your studies. Again, I was really excited to see this work when you guys reached out to me. I'm happy that it's being done, and I'm also really happy that it's being disseminated, because I think, as most of you know who are interested in process data, it's relatively new, particularly in the field of universal design tools, as Juanita had mentioned. And so the more we can all discuss this as colleagues and as a field, I think we can make some really good progress in this area. So let's see. There we go. So the presentations were great, and I got a chance to read the paper as well. And one thing I just wanted to mention is what is going on behind the scenes when we're working with process data, and that is trying to make sense of these big data files, doing data mining, data cleaning, and then mixing that with some statistical models, and then hopefully theory. So this is just available on the web. It's just a little screenshot of some of the types of process data that are available for NAEP. And I just wanted the audience to sort of think about how we go from making sense of these lines and rows of lots of data to actually theories about that will help the field. And I think our speakers did a great job of thinking through those things. What I want to encourage all of us to do, and I'll just have some general comments, when we're thinking about process data, is to think about what the field needs, and in particular in this area in terms of text-to-speech as a universal design tool. Again, thinking about what information students and teachers and assessment developers need, and we all need to try really hard to not be opportunistic when it comes to analyzing this data. And again, I think that the three presenters here did a great job with that. So when I've thought about what information that we can get from process data and how we can help know more about the use of universal design tools, a couple questions that come to mind for me are improving the information that we get from assessments. So I know Juanita gave a little bit of a background on research on accommodations. Before we had digital assessments, assessments were delivered in paper, obviously, and if any of you have experience with working with state data sets, you would likely have some indicator for whether a student was assigned an accommodation or got an accommodation, but we never really knew if they actually used it, if it was implemented correctly, if they did actually get it. So this is a real opportunity to actually see use on particular items. Some of the other research that has been done in the past has been on the differential boost and the interaction hypothesis, has been with experimentally designed studies. And in those cases, the researcher had control over the use of read aloud, for example. And so they would know that the students in their study were using it on each item. But that was a lot of small samples, and we really couldn't generalize. So I think this process data is going to give us an opportunity to look into this more. Let's see here. I think this work is really going to contribute to improving accessibility of the assessments. And there's a whole body of literature on whether teachers are giving students the opportunity to use the most appropriate accommodations and universal design tools in the classroom. And hopefully the information that we get from this can help with that as well. So I'm going to I have a few comments for each of the studies. The first one on Sue's study evaluating the text-to-speech tool using NAEP process data. I was really glad to see this information that's descriptive and exploratory. We really need to know, are students using text-to-speech? How many items are they using it on? Because if they're not really using it, we can't do any analysis on that. So I was glad to see that there is information where students are using it and there's variability over items. So that was good. Just a couple of thoughts I had on this. One, and this is probably for all the studies as well, is the operational definition of text-to-speech use. So here in these studies, they've defined it as using text-to-speech on at least one item. I've done that as well in my research. It's sort of the easiest first thing to do. But I really like to see us all, not just with this paper, but in general, as we continue to use process data, is getting more towards an optimal definition of text-to-speech use. And so one way I was thinking about it, and I don't know how to quantify this as well yet, but thinking about it in terms of you used it on all items in which it is expected to be beneficial. You use it on some items on which it is expected to be beneficial. You use it on no items where it's expected to be beneficial, or it's not expected to be beneficial at all. So I think that is going to take a lot of work, and that's going to be a combination of all the different kinds of analyses we've done today. But for those of you who are continuing this research, I'd like to encourage you to think about the definition of text-to-speech use so that we can all benefit from that. I did have a question, not to answer now, but just for you to think about the meaning of turning text-to-speech on and off without reading the text. So I was just kind of wondering, are students doing that just on one item? If they're doing it on more than one item, what does that actually mean? Are they, you know, is it a distraction? Are they just sort of looking? Are they not knowing how to use text-to-speech? So thinking about that in the future and how to figure that out is just something I was thinking about. And then I just wanted to see a little bit more justification for comparing the groups that you chose in the study, so accommodated, extended time accommodation, and non-accommodated students. In particular, as you all know, read aloud is sometimes an accommodation on the state assessment, but then it is not an accommodation on NAEP, it's a universal design tool. So I think that non-accommodated group could include students who use read aloud on the state assessment, but that's not marked down, and so they wouldn't be in the accommodated group if they're not having any other accommodations. So just thinking a little bit more through who are the students that we would expect to actually benefit from that, from text-to-speech, and might you have information maybe from the student questionnaires and the teacher questionnaires about whether they used it on the state assessment. And then I'll talk about this more with study 3, but just how can these results inform study 3. So I'd like to see sort of a mix of how many students used text-to-speech on particular items, and then what was the text complexity on those items. For the second study, Juanita study, exploration of text-to-speech using the differential boost framework. Again, I liked seeing this study, and the analyses were in the tradition of previous studies using experimental or operational paper-based assessment. So looking at that differential boost hypothesis and the interaction hypothesis. I think we need that. We need to see whether the results hold the same for NAEP and for the universal design tool as we have with the previous studies. But I'd like to see this work go a little further and take advantage more of the data that's there. So for example, adjusting for student characteristics related to the need for text-to-speech. And this may be something that's not available in the current data, but maybe we could think about how to get that into the assessment data collection going forward. So the number of items that use text-to-speech, disability types, whether they use it on the state assessment, those might get us closer to defining the groups based on their need for text-to-speech. And then I would like you to consider expanding the definition of use to take into account all of the items, particularly when you're using the plausible values or total scores as the outcome. So how can we, right now you're saying if they use it on one item, but maybe there's a difference between students who use it on a lot of items or who use it on some items. And then I would also be really interested in an expansion of this work to focus on analyses at the item level, in addition to at the level of the total scores or plausible values. So again, taking advantage of that individual item level use and how that relates to performance. And then the last study, Ruhan's, exploring read aloud sentences to understand learners' text-to-speech use tendency. I liked seeing this paper as well. I'm a little less familiar with natural language processing and text complexity, but all three of the papers, by the way, were very nicely written. For this one, I kind of wondered about the purpose of the analyses, and this could be because maybe this isn't my area as well, but I wondered about whether this is to improve this particular NAEP assessment or how this would be extended to other contexts. So would you be recommending that this kind of analysis be an operational endeavor that should be done during pilot testing to reduce text complexity? So thinking about how you were looking at specific items and trying to figure out why students are using the text-to-speech more or less, I was thinking about, well, how does that relate to other contexts as well? And then I wondered if you could take into account how students have used text-to-speech on other items in your analyses of a particular item. So for example, item 12, I know you mentioned that one a lot. Who were the people that are using text-to-speech on that item, and did they tend to use it on other items as well? Or the one where I think it was item number 4 or 5, when not very many people are using that, is it a characteristic of the item, or is it just because a couple of people who only tried it on one item did it there? So again, trying to get more information from the test, from performance on all of the items into your analyses on a particular item. For the finding that, well, I think it was 50% of the sentences were read aloud the item stems. There, I was just wondering whether that is consistent with what some states allow on their state assessment. So maybe some students are used to only reading the item stems, and that's why you had that finding. So just be kind of interesting. And if you have information on the states where you found those, that might be an interesting thing to add. And then your focus on item 12 made me think about considering adding words or sentences on a page, because the individual sentences may not have been complex, but there was a lot of text. The sentences may have been long, but there seemed to be a lot of words on the page. So maybe that would signal to students to turn on the text-to-speech and use it when they see a lot of those items. I mean, a lot of that text. And then I was wondering whether, as an extension, whether total time spent on an item could provide insight for items such as number 5. Again, that's the one that we were just kind of talking about, trying to figure out why students are using text-to-speech on that one. Perhaps maybe the time spent could give you some insight into them thinking that that sentence construction was more complex than what your statistics said. And then I'd just like to see as an extension for you to consider adding some predictions. So do text characteristics predict either text-to-speech use or performance on some items? I think that would be an interesting question. And then again, just linking back to study number 1. So you had information on the text complexity and how many sentences were read, but I would like to know how many students then used text-to-speech on those different items. Overall, again, I thought that this was a great set of studies. Just some closing thoughts in general. One is, how can we continue to improve data collection with respect to looking at accessibility and universal design as digitally based assessment evolves? So one thing, if you start to move into looking specifically at students with disabilities, we would want to make sure that, or try to improve the information that we get from the assessment system so that we can have some idea of needs for text-to-speech. So that might be in terms of the survey questionnaires, or asking students, or maybe it's an empirically based way of figuring out student needs. I'd like to encourage everyone to continue research on universal design tools that bridges data mining, statistical models, and theory. As I mentioned in the beginning, there's a lot of data here. There's a lot of sort of coding and things that need to be done. But then on the other side, we want to be able to have results that are meaningful and that are interpretable. And so we need to bridge that across the data mining and the theory. And then I just encourage the 3 authors and everyone listening to continue to get the work out there so others can build off of it. This is a relatively new field. Item level information for universal design tools and accommodations. I think it's really going to take us building off of each other's work to get something really good out there, but I'm very optimistic. So again, thank you all for the opportunity, and keep up the good work.
Thank you so much, Heather. Thank you so much for reliving all of our future studies, actually. It was great. Thank you so much. Definitely, we really appreciate your reflections. All of them were fabulous. And we had one more slide, but I think we don't need to go over it. Just to say the implications in the future studies. We agree with everything that you said, and also some other stuff. We definitely continue to work on, on this, and we believe the value of the process data, not just in NAEP, not just in mathematics, especially reading science items, especially with reading. You can imagine how it may expand further. Definitely, the pilot data sets will be more useful, and prediction will come into our way very quick, or maybe quicker than we imagine. So we really appreciate all of your reflections. So I don't know how many people so far, are there in the meeting now, but yeah, so if any other questions, please unmute yourself. And we are happy to answer. And also, I would love to share our email address at AIR. So if anybody has any questions about the NAEP process data specifically, we are happy to answer any questions further. Yeah, I think we are good. So we have 7 minutes left. Um,
No,
so
I
I would
think we
love,
had a,
yeah, okay.
I think we had a pretty good turnout for the end of the day. Thank you all for sticking with us.
Yeah, and I would love to ask
Yes.
Erin if she wants to
Yeah.
do. Yeah, thank you so much, everybody. We really appreciate
Yeah.
all of this
Thank you so
interaction on
much.
a Friday night now.
Yeah.
Thank you, everyone. Have a good night.
Okay.